Hello everyone, my name is Taiwo, and in this video I'll be talking about a technical problem, a technical challenge that I had to solve. Essentially, the problem was to design and integrate Celery and Redis into a Django application. We wanted to use the Django Web Application to process and gather data from Amazon SP API with a certifiable reload rate of 20%. To give you a bit of context about Amazon SP API, you could use it for a lot of things, but for this video, we'll be using a case study of getting reports from the API. To get reports, you'd have to go through three processes. The first process is to request a report. Then you basically keep checking for the status of the report. The moment it's complete, you then get the result of the report. So initially, I had all of these functions written that would connect to the API. I'll do each of them on our Django application hosted on AWS. So that when the user makes a request, it basically goes through the process flow and returns a value back to the user. However, the first problem we experienced was a server timeout error. And the reason for that error was because, as I mentioned before, the get report status oftentimes has to be on a loop because we have to wait for the report to be complete before we now run the result. And so many of the times we run into a timeout error. That was the first issue. Second issue was something was caused by something Amazon introduced, which was called a rate limit. So a rate limit is essentially saying that when you make a request to one of the Amazon's endpoints, you have to wait a couple of minutes or seconds before you can make another request. So assuming the user has sent a command to the backend to get a particular request report, and second user tries to make that same request, it returns an error because at the moment the request report is not currently available. And so that's what I called an API throttling error. And then finally, the other thing was a component redundancy, which was not really an error, but was a concern because these two functions were not usable unless the first function ran. And that just seemed very redundant. So collectively, the three of them led to a failure rate of 90%. And so the objective was to bring this from 90 to below 20. The first thing I did rather was to integrate Celery workers. Celery is basically a distributed task queue. So you have tasks that queue up and then they can run, they run on the background asynchronously. And they basically use the first out approach. So the first task that comes is the first task that is attended to on a queue. So it's a queue data structure, obviously. And so I don't want you to confuse that with what I have here. This is not a queue, this is just a design. And so I had these three functions in my Celery. I had them as Celery workers, right? And so to use Celery, you need something called a message broker. There are different types, but for our case, we use Redis because it was the easiest to use. There are other types like RabbitMQ and I think MongoDB and others, but we used Redis. And so when the user makes a request to start a report process, you basically send a message to Redis message broker, which then triggers a Celery. Now, although I say we did that, the truth is that Celery handles all of that in the backend. And so when we request a report, it runs through the same process as we've done before, and then the result is stored back in a database so that the user can say, I want to get the status of my report, or I want to get the data from my report. And we just look into the database and return it back to the user. Immediately, the first thing we do is get rid of our server timeout error because everything now runs asynchronously in the background, independent of our server. And so they run asynchronously so that by the time they're done, they just install it rather into the database. And so that was immediately gone. And that brought down our failure rate to 50%. The next approach that we took for optimization, basically having the same function. We had if you look at it from a design view, we basically stack them. We still have our message broker like before, but I introduced a few more components. The first was the Redis cache, which is kind of like a temporary database, so that when the user sends, when the user sends an information rather to the backend, I want to get a particular report, it is stored temporarily in the Redis database. The second thing I created was a new report checker, which basically runs every 2 minutes to determine which of these blocks should run. It runs every 2 minutes with the help of the Celery bit scheduler. Right? The Celery bit scheduler runs continuously, essentially, and then basically checks at any point when it's running. If there's a task that needs to run, it sends a message to the Redis message broker, which just sends it to the report checker. The report checker then gets the information from the Redis cache. Remember, the cache holds information about our reports that needs to run, that needs to be processed and analyzed. And so the report checker takes information from there and then determines which of these blocks needs to run. If it's a new report that's just coming from the user, it will obviously, first of all, needs to be requested. And once it's requested, okay, before I go on, I should probably point out that because we cannot run everything concurrently, we got rid of the component redundancy issue. And like I was saying, we have our request report. By the time the request report is done or any of these blocks is done, we update the data back in the cache. So to give you kind of an example, when I make a new request, I set it to the cache. The new report checker picks it up, requests the report. By the time it's done, it kind of has a flag to it that says report requested and stores it back into the cache. Now I go again, the new reporter checker, because it has been requested, it goes into the report status. And then it doesn't have to put it on a loop. It basically just goes into the report status. If during the time it's running the report status, the report is not ready, it just goes and says not ready. And it keeps going over and over. So rather than have a loop, I have a scheduler that runs my report checker every 2 minutes. And by the time it's complete, it puts a flag that says complete and then goes back and runs the result. And so our new report checker solves the API throttling because we don't have to run it on a loop anymore. We have a nuance in our new report checker that basically determines when one function should run into where. And so at the end of the report results, we do a post analysis, like cleaning or data curation or some data analysis before we start data in the database. Now, because we've gotten rid of the last two problems, our failure rate went down to 35%. I'm sure you're probably wondering what's going to happen now. But the truth is, the remaining, because we introduced our Redis cache, we now had a new problem called data races. And it's basically caused because we're reading and writing into the cache at the same time. And so to get rid of that, I used something called Redis logs, and that got rid of data races, reducing our failure rates to 15%, which was ultimately what we wanted to do. So this was ultimately the solution that we had, and we had to deploy this on AWS. So the first lesson I learned was that installing Celery on Windows is such a problem. It's a headache. And for anybody, Celery and Redis are easily installed on Linux and in Mac OS, but it's always recommended. I know some programmers rather use Celery. So I would recommend if you're going to, some programmers use Windows. I recommend that if you're going to use Windows, then you should install something called Windows Subsystem for Linux because it allows you to kind of simulate a Linux environment, which is great. Another thing I also found out that even though we had this application running perfectly locally on our server, by the time it was time to deploy to AWS and Elastic Beanstalk, we ran into a lot of issues because deploying locally it works, but on the server it's a challenge. And so I had to liaise with a lot of DevOps engineers to actually make this work. But once we got it running, it lasted for months, years before we had to do any more plugging. And then finally, looking at the application, at the time when I developed, the only objective I had was to reduce the failure rates. But after coming back to it, we found out that this is actually a good system that can be designed using the microservice architecture. So if I were to redevelop this, I never had the chance to because the project was closed. But if I were to redevelop this, I would definitely use a microservice architecture. And I think I forgot to mention that, well, I think that's pretty much it. Yeah, those were the major lessons I learned. It was an interesting experience. While I worked at the project, I learned a lot about Celery. I learned a lot about Redis, learned a lot about Bits. I learned a lot about AWS as well. It was one of the major contributing factors to my knowledge as a developer today. Thank you for listening, and I hope you also learned a lot as well.